Hello troops, I am here with you today for our maths lesson where we're going to move on and build on what we've done already this week, and we're going to have a look at multiplying a two-digit number by a two-digit number. All right, so as always, you know the drill. Before we do, pause me, have a go at the questions, and then I'll reveal the answers in a minute. Okay, so some really simple ones there. Number 2, I'm hoping didn't give you too many problems. I guess with that, the main thing is thinking out what's the most efficient method. Okay, remember, we're always striving for the most efficient and the most accurate method. Okay, so if you want to have a little marky mark, again, any marvellous mistakes. If you've made a marvellous mistake and you can't see where it is or what it is, just drop me a message and I'll be happy to help you find it. Okay, so to begin with, now we were hoping, had we been in school, this would have been a really practical hands-on lesson, but no fear, because the things that we were going to do practically with physical base 10, we are going to have a chance to do. Hopefully you can have a go at drawing it yourselves. Okay, so begin with over here, what number is represented below? Remember, we've got our hundreds, our tens, and our ones here. So if I start by looking at my ones, and again, it'll probably take me a long time to do it with my funny way of kind of carrying these over. But you might want to cross them off as you go. So I can see I've got 9 ones there. You could cross them individually. Like I said, I think it would take me too long if I do that. So I just go wham, bam, thank you, ma'am. Got 9 ones. I've got 1, 2, 3, 4, 5, 6, 7. I've got 12 tens. Now, question. Can I leave it like that? No, someone made that mistake yesterday, didn't they, in one of our questions? No, if I've got 12 tens, we know that 10 tens are the same as 100, and we carry it over, don't we? So I put a 2 here, and I carry my 1, and then I've got 4 hundreds plus the 1. So the number I've represented there is 529. Okay, now that's one way of doing it. Am I right in saying that there would be multiple ways of doing that? I could have just had 500s, 2 tens, 9 ones. I could have had my tens made up by some ones. So what I want you to do, and I realise I need to wiggle this up because my big old head is in the way. Could you please have a go at drawing base 10 to make the following numbers, these 3 here, and have a go. Some of you might want to just have one way of doing each one. Some of you, can you have a go at making it in different ways, perhaps 2 or 3 different ways? Okay, so pause me here. When you're ready, we'll move on. Okay, so the reason we've got you having a bit of a play around with base 10 is that base 10 is one of the methods that can be used for multiplying a 2-digit number by a 2-digit number. So if we look here, Tia has used it to solve the question 23 times 22. Well, how's she actually done that? Let's have a look. If we look here, we've got along the top, Tia has made 23. I know it's 23 because I can see 2 tens and 3 ones, which would make 23. So along the top, she's made 23, and down the side, she's made 22. Can you guys see that? Yeah, so first step is she's made her length and her width of her shape. This kind of links to what we were doing about area. Okay, next she's multiplied the length by the width to find what's inside, again linking to that area. So you can see there's a kind of a couple of ways you could look at this. If I start in my tens, okay, I could do this individually. I've partitioned it, so I've got 10 times 10 to make my 100 here, 10 times 10 to make my 100 here, etc. Or I've got my 10 times my 3 to make my 3 tens. Alternatively, I could just look at it, instead of looking at it as each separate 10 and 1, I could say, look, I've got my 20 times 20 in my tens. That's made 400. I've got my 20 times 2. That's made 40. 20 times 3, which has made 60. And 3 times 2, which has made 6. Okay, so essentially she's made her length, she's just made the numbers using base 10, and then she's filled in the kind of area bit with the numbers that it would make by multiplying them. Okay, now for me personally, this actually takes quite a lot of time to get my head round. So don't worry, we're going to explore a couple of different ways of doing this. But if you would like to have a bit of an experiment, we've got 3 number sentences down here at the bottom. If you want to have a go at creating the same sort of model that Tia's used, using base 10, so draw out for this one along the top, make 32, 3 10s, 2 1s. Along the side, 24, 2 10s, 4 1s, and have a go then at filling in the bit between it by multiplying. Okay, when you're ready, I'll show you the next way of doing it. Right, like I said, I think that bit is a lot easier when you've actually got the base 10 in front of you, but no fear, I trust in your ingenuity to try it out at home. If we have a look here, so again, talk to your partner or talk to yourself. What calculation does this represent? If we have a look, well, again, let's have a look. This top number is going to be my first number. That's 2 10s and 2 1s. So that's going to be 22. Do you agree? And then along the side, we've got 2 10s, 3 1s, 23. So the question is 22 times 23. Happy with that? Cool. Now, I'm hoping this is going to go smoothly. If not, I might have to rewind a bit and do it again. If I look, I'm going to break it down step by step. So I'm going to do 10 times 10, I'd get my 100 there. Or, in fact, that would be one way of doing it, breaking it down. Or I could go, right, 20 times 20, it's going to equal 400. And I'll know that I've got it right because I should fill the space where it would go. Okay, so I've done this bit by this bit. Now I'm going to do these 10s by these ones. So I've got 20 times 2. So I need 2 lots of these 2. Okay, so if I put that there. Again, you can kind of see, I hope for you guys, you can see I'm kind of just filling in the gaps. All right, I'm hoping technology has not failed me so far. Woo, woo. Ooh. Spoke too soon. There we go. And then I've got my 20 times 3. So this time I'm going to use them the other way around. So got them there. So 3 lots of my 20. And actually, I think maybe this way it's a little bit clearer to see. Would you agree that I've got 3 rows of my 20 there? Yeah. And then finally, I've got my 3 times my 2. So either 2 lots of these 3 rows or 3 lots of these 2. And the only thing is I haven't enlarged my ones there, guys. So you just have to imagine they're a bit bigger, okay? There we go. So if we look here, I've got my number. Oh, gosh, sorry, this has taken a lot longer than I expected. I reckon you guys have probably done about 3 by now, haven't you? Right. Am I finally there? Come on, right, okay, here we go. So if I have a look, I've partitioned it and I'm going to count my hundreds, my 10s and my 1s. So I can see here I've got 400s, which is the same as 400. I've then got 4 10s, which is the same as 40. I've got another 6 10s, which is 60. And then I've got my 6 at the bottom. Now, I know that, oh gosh, that was a bit rubbish, wasn't it? There we go, double swell. I know that 40 and 60 go together to make 100, another 100, so I would carry that. So my answer would be 40, add 100, add 6 would be, sorry, I said 40, didn't I? 400, add 100, add 6, which would be 506. And again, I think, that was quite a long way of doing it. But I think the main thing with this, guys, and for me, I guess the biggest thing that comes from it is that visual understanding of the number I'm creating and being able to see how 22 times 23 makes 506. For some of you, you might go, do you know what? I think this actually makes it more complicated for me. That's fine. We just want to show you a couple of different methods of doing this, okay? Because if I go onto my next screen, you can see we've got kind of 3 or 4 representations here for Essin has adapted it to solve 44 times 32. Okay, so if we look in the middle, instead of using base 10, Essin has used place value counters. At the bottom here, instead, and I think it's the same over here. Yeah, they're the same. So yeah, at the bottom here, they have kind of just done the multiplication. So 30 times 40, 30 times 4, 2 times 40, 2 times 8. And then over here, we've got kind of an addition to add them all together. Okay, so what I suggest, again, maybe just pause me here, have a look and see which one of these methods you prefer. And again, maybe have a go at using them out to have a go at a couple of these questions at the bottom. So are you going to use base 10? Are you going to use place value counters? Again, just drawing them. Are you going to go straight for the calculation and add them up? Totally up to you. Okay. Right. Okay. So we've got a mistake here. Wilbur's made a mistake when using the area model. So he's used the place value counters. So if we look in here, so remember we're times in. If I put a times here to remind us, we've got 20 times 20. Now, if we look, I know that would be 20 times 2 would be 40, 10 times bigger, 400. So this bit is correct here. We've got 20 times 5, which would be 100. Yep, that bit's fine. We've then got 20 times 3. Now, again, we should be able to do 2 times 3 is 6. 10 times bigger would be 60. Wilbur's only got 4 tens here. Okay, so he should have added another 2 tens. I believe what he's done there is 20 times 2. Okay, so we can see that by partitioning, he's forgotten or done one part of the partitioning incorrectly. Okay. Right, final thing I'm going to show you, and I'm aware I'm a bit limited on my screen time here, is just how I would do this with the formal written method. So we've had a look at practically drawing it out. This is the formal written method, 2 different ways, and you can decide which one you like. So we've got 24 times 22. A bit like we did yesterday, the first thing I'm going to do is I'm going to times the top number by my 1 digit. So I'm going to do 24 times 2. So 2 times 4 is 8. 2 times 2 in the tens column would be 4, 48. 24 times 20. Now it's going to be exactly the same, except if it's by 20, my answer is going to be 10 times bigger. I'm going to put a 0 here to hold my place. It is so important to keep that there, guys. So now I'm going to do the same. So 20 times 4, 2 times 4 would be 8. However, it's 1 column along because it's 10 times bigger. So I'm going to put my 8 here. And then again, 2 times the 2 would be 4. But it's 1 more column along. Last thing I need to do is add those things together. So I've done 24 times 2. Yep, 24 times 20. Partitioned it twice. Add it together. 8 add 0 is 8. 4 add 8 is 12. Carry the 1 over. 4 add the 1 is 5. So my answer should be 528. Now, the other way of doing it is you can break it down even further. So I can go, right, 2 times 4 is, 4, 2 times the 4 is 8. 2 times the 20 is 40. Apologies for my dodgy handwriting here, guys. Then we've got, so I've done the 2. Now I'm going to do the 20 times the 4. So 4 times 20, which will be 80. And then I've got the 20 times the 20, which will equal 400. And I should still get the same answer. I've just broken it down into more steps. So if we have a look, I've got 8 here. I've got 4 add 8 is going to equal 12. Carry the 1. 4 add the 1 is the 5. So you still get the same answer, but it's just a slightly different method of doing it. Personally, I think the one on the left, just breaking it down into the 2 steps of doing the top by the 1s, the top by the 10s, I think that's quicker and probably less areas for mistake, but you must remember to put that 0 to hold the place. Okay, now today is a lot of new learning, so don't worry if you're not sure. Tomorrow we'll also be looking at 2-digit by 2-digit. On the screen here, I've got some fluency questions. Have a go at them, as many or as little as you want. And then there are also some problem solving and reasoning on the website. If you want to pause me here, have a go, and then I'll reveal the answers. I've got 10 seconds left on my screen. Hopefully you've paused me. Here are your answers. Mark them, see how you got on. We're going to revisit tomorrow. Okay? Bye, guys.